All right, we're going to continue to solve log equations. In the last video, we did log equals log type. This time we're going to do log equals a number. Okay, so this is going to be a little bit different than what we looked at before, but log equals a number means we're going to condense. So again, we're going to use our properties to condense. We have to isolate the logarithm, which means we need one single logarithm. And then we're going to write it in exponential form. If you remember back when we first started logarithms, the first thing we did was rewrite from logarithmic form to exponential form and exponential back to logarithmic form. So if you have forgotten that, go back and review that video. And then we're going to solve, and we're still going to check for extraneous solutions. So let's get started. So number one, you can see we have a log equals a number, so we're going to rewrite in exponential form. If you remember, we do this, the base to this power equals this. And we call this the cloud method because we just kind of go around. So we're going to say 2 to the 6th power equals x minus 4. So that's how we write it in exponential form. Now, when we look at this, we can say 2 to the 6th power, and we can evaluate that and get 64. So 2 to the 6th power is 64 equals x minus 4. And then I'm going to add 4 to both sides, and x equals 68. All right, and then you can plug it in and check it. So if you put 68 here, 68 minus 4 is 64. And then 2 to the 6th power is 64. So if you plug that in, it's going to work. All right, for number 12, when it says condense and isolate, that means we need to get rid of some stuff first. We need one single logarithm. We have this minus 7, which before we do anything else, we can add that to the other side, because we want to condense this and make it one single logarithm. So I'm going to have log base of 3 of 4x plus 8 equals, and if I add 7 to negative 3, I get 4. All right, now we're going to use the cloud method, as some people call it, or we're going to say this to this power equals this. So we're going to rewrite it in exponential form. So 3 to the 4th power equals 4x plus 8. And then if I evaluate 3 to the 4th power, let's see what I get here. Let's see. 81. That makes sense because 3 times 3 is 9 and 9 times 9 is 81. So we get 81 equals 4x plus 8. And I'm going to subtract 8 from both sides, and I'm going to come over here, so I'm going to get 73 equals 4x. And then divide by 4, and x equals 73 over 4. Now that's kind of a nasty fraction, but you do need to plug that in and check it. What I would do is just take my calculator. Your calculator, if you have a TI-84 and it's the updated version, you actually do have you have several logarithm buttons on your calculator, but if you go to I'm going to have to play around with it and let you know. But if you go to your calculator, there is a place. It's under math. If you click on math and scroll down through there, there is a place where you can do log base button if you have the updated version. If your calculator is not updated, then it's not going to be there. But I would look for that, and that way you could just type this straight in and check it. I'll try to make a video on that so that we can see how to use your calculator to do that. All right, let's look at example 13. The first thing we're going to do is see that because we have this plus sign here, that means we've got to use our properties of logarithms to multiply these. So the first thing I'm going to do is rewrite this as log of 2x. Multiplication comes from addition. So since this is addition, when we condense, we multiply these two to put them together. And then that's what we get. All right, also in one of the other videos, you learned that if there is no base, then it is assumed to be a 10. It's a common logarithm, base 10. So we're going to go from here to this power, and then back to here again. So no base means common log, base 10. So 10 squared equals 2x squared minus 10x. All right, now we're going to set this equal to 0. So I'm going to have 2x squared minus 10x, and 10 squared is 100. So if I subtract 100 from both sides, that sets this side equal to 0. Now you will need to factor. We're going to factor out of 2 because they have a common term. So I'm going to factor out of 2. That leaves me with x squared minus 5x minus 50. And again, we factored in Math 2. We factored in the first semester of Math 3. So factoring is something that is just review. All right, once you factor, you've got to, we just dropped the 2, but then we've got to factor this further. All we did was pull out the GCF. Now we're going to say x times x is x squared. What multiplies to give me negative 50 and adds to give me 5. So that's going to be 10 and 5. I need a negative 5, so it's going to be a negative 10 and plus 5. All right, once I do that, I've got to set each factor equal to 0 using the zero product property. So I'm going to come over here to the left and say x plus 5 equals 0 and x minus 10 equals 0. And then I have to solve. So subtract 5. X equals negative 5, and then I add 10, and x equals 10. So I need to check these two answers. So I got negative 5 and positive 10, and I need to plug those in. So if I take negative 5 and I plug it in here, that gives me negative 10. And then negative 5 minus 5 gives me negative 10 here. And then I multiply those because that's addition. So property says that I multiply those. So negative 10 and negative 10 give me 100. And my base is 10. So base of 10 squared is also 100. So that one will work when I plug it in. All right, 10, if I plug in 10, 2 times 10 is 20, and then 10 minus 5 is 5. So 20 times 5, because again that changes to multiplication, 20 times 5 is 100, and again base 10 squared, so that one will work as well. All right, I'm going to change colors here just to make it a little easier to see the different problems, even though there's a line here. But anyway, so this one, number 14, if we look at number 14, it has the negative in the middle. So since we're subtracting, we know that came from a quotient property. So to rewrite this in condensed form, we're going to have log of x squared, and then subtraction turns into division over 4, and then that equals 2. All right, again, this one is a common log. Since there's no base, that's assumed to be base 10. So we're going to say 10 squared equals x squared over 4. 10 squared is 100. And then we have x squared over 4. Since we're dividing by 4, to get rid of that, we move it to the other side by multiplying. So 4 times 100 is 400 equals x squared. And then we take the square root of both sides. Remember, when you take a square root, we learned this back in a different unit when we were talking about radicals. When you take the square root of a number, you have a plus or minus that number. So the square root of 400 is plus or minus 20. All right, and that means you have to check both answers to see if it's extraneous or not. All right, so 20, if we plug in 20 here, again, I would try to use my calculator to see if this will work. So first use 20 here, and then after you use 20, do negative 20, I don't know, right? Not 21, 20, positive 20 and negative 20. But if you have a TI-84, which is the calculator that I use, that's the calculator we provide for the EOC, and that's the calculator that is most accepted on the ACT. So we use the TI-84 mostly. If you look on the TI-84, if you're looking at it, you go straight down the left-hand side and it says LOG is the fourth button up from the bottom. All right, so if you hit that button, that assumes it is base 10. The only way you can use this button without being base 10 is if you do change of base formula, which we also learned the other day. But anyways, this one is a base 10, so you can type in 2 log of 20, and then close the parentheses, and then minus log of 4, and hit enter, and that equals 2. So when we plug this in our calculator, we can see that 20 definitely works. So then if I go 2, and I type in log again, and this time I'm going to put negative 20, and then minus log of log of 4, sorry. And then I hit enter. It says non-real answer. So that means negative 20 would be an extraneous solution. So this one will have one real solution. And again, sometimes it may be easier for you to check these with the calculator. So I'm just going to take off. Let's see. Let's put x equals 20, and that's a solution. X equals negative 20. I'm going to mark that one out because that one is extraneous. That one's non-real. Okay. All right, we're going to look at one more before time runs out, and number 15 has log base 6, and we have x plus 9 plus log base 6 of x. So we know that that plus turns into multiplication. So I'm going to have x times x plus 9 equals 2. And then I can rewrite this as exponential. So I'm going to have 6 to this power equals this. So I'm going to have 6 squared equals x times x plus 9. And then 6 squared is 36. And I'm going to have x times x is x squared plus 9x. Okay, again, I'm going to set this equal to 0 and then solve. So if I set this equal to 0, I'm going to subtract 36 from the other side. So x squared plus 9x minus 36 equals 0. From there, I can factor. Again, if you need to review factoring, you can review stuff from last semester or even back from last year in Math 2. But factoring is something that's very important in a lot of different units. So we are using it again, even though we've used it in 3 or 4 different units this year already. All right, so to factor, we need x times x is going to be x squared. And what multiplies to give me 36 and adds to give me 9. So that's going to be 12 and 3. And I need a positive 9, so my bigger number is positive and this number is negative. All right, that's a negative. All right, like before, anytime we're solving, we're going to set our factor